All right, I guess we're ready to go for the review. Any questions before we start? All right, if there's no questions, I'll let you guys work this, and then whoever gets it done first can start writing how they worked it and got the answers.
What chapter should I be looking at for this one?
This is 4.1. Yeah, so this one, 4.1, if we look at the applications on page 342, those 8 problems, it could be basically any of those chosen out of there. So it could be a grouping and you could get any of those 8. And again, of those 8, you're not going to get the same actual numbers. Like for this one, if we had foxes on the test, you wouldn't get the year 2000 and 28,600 and things like that. You'd get different numbers. So it'd be kind of individually, everybody's going to have a different kind of problem. So
What page did you say that was on?
this is on 342. That's where it's at on the exercises. You still working a calculation out there? Is that what you're doing?
It's all to the eighth, right? Just like the 1.05 is to the eighth power.
Yep. Well, it's the 1.05 is to the eighth. Just that part.
Not the 28,600, because then you get
No.
like a crazy number.
Yeah, it's just this part here that's to the eighth. All right, so how did you get your equation here? Where did these points come from for A and B?
I looked at the notes in class where it was the application problems, where it was like 1.39 billion in 2013 with a different growth rate. So I just kind of copied that with the starting number from zero, like the point would be like 0.28,600, and then the growth rate of 5 would make it 1.05.
Okay. Yeah, and so that really just comes from the 0A. And so the A comes down here, then that's your growth rate. And then you just plug in whatever your T was in this kind of time from 2000 to 2008. You put that 8 in there, and then you calculate that, and that's what you get. Okay, so that looks good. All right, so the next one here, this one comes from page 340. And so it's going to be something like those 18 to 22. It's going to be like one of those exercises there. So show how you do it one way with the work, and then we'll see if that matches what the calculator gives us.
Is this from 4.2?
No, it's still 4.1. It's on page 340, the 18 through 22. So we lost on this one, or are we working on it still?
I don't really know how to do it.
All right. So this one, it's going to be an exponential, and since it's still in the first section, we're just going to use the y equals a b to the x. And then what we do is we plug in both of these points for x and y and solve for a and b. So the first one, y, is 5/4 equals a times b to the -1. And our second one, we have 80 equals ab to the second. Now what I'm going to do is I'm going to solve the first one for a. You can solve the second one for a, it doesn't matter, and then plug it into the other one. And so if I solve the first one for a, what I'm going to have to do is multiply both sides by b, and so I get 5/4 times b. Because this is when you have b to the -1, that really makes it a over b. So to get rid of it, you have to multiply by b. Now if I take that and plug it in here, I get 80 equals 5/4 b times b squared. Now, if I get rid of the number there, I'm going to multiply by 4/5, multiply that by 4/5. And so when I do that, I get 64 equals, and b times b squared is going to be b cubed. Now I'm going to take both sides and take the cube root of each of them. And so on the right, we get b. On the left, we get 4. So that's our b that goes back into this equation. Now we solve for a. Well, a is just going to be 5/4 times 4. So a is equal to 5. And so that's our other key point. So now we just have y equals 5 times 4 to the x, and then that's going to be our final answer for the function through those 2 points. So do we remember that one now? It's been a while.
Yeah, I was looking at the class notes for it, and I think just the 5/4 messed me up because on the one in the notes it was like a decimal, which was easier to work with. I was just confused.
Yeah, well, this one doesn't turn out too bad. I mean, with the 4/5 and 5, everything cancels, and so it's not too bad working with it. But yeah, when you see it initially, those fractions kind of look bad. But even in the book, they've got one that's -1 3/2 and 3/24. We've worked with 3/1 5/4, and I think we did also the -2 6 and 3/1. So some of the times the actual whole numbers work out really nasty, whereas the fractions, when to make it work, they actually work out pretty well. So that's how I would do that one. All right, anybody get that one done?
Where is the graph like hitting a solid number besides 0, 4?
Um, what it looks like to me is it's at 1 2. That's what I went based on. Is what I used the 1 2. So this is kind of like the ones on page 354, number 41, and number 42. Those are similar types of graphs as far as how they behave and what it's going to be like on the exam. So. So how are we doing on this one?
I already got it completely wrong, so I don't really know.
Oh, I already got it completely wrong. Okay. All right. So on this one, what I would do, I would look for that horizontal asymptote first. And so if I look here, it looks like uh, their horizontal asymptote is the y equals -7. So that's the horizontal asymptote. Okay. And so when we have those, that means we've moved down because when we have exponentials, y equals 0 is their asymptote. So that means we've moved down 7 units, or d is equal to basically a -7, because with these we had the y equals a b to the x, and then if we moved up or down, then we added or subtracted a d. So we're going to subtract 7 here. Then what I would do is, let's go backwards from what we have to get to where it should be and see how we do that. So if we're here at -7 and we need to be here at 0, basically we're going to add 7 to both of the y values. And so for the 0 minus 4, if we add 7 or go up 7 units, we're going to get 0, 3. And on the other one, we'll get 1, 2. If we add 7, that's going to give us 1, 9. Okay, so that's going to be kind of our points translated up here after, because we shifted down. And then what we know about the normal equation, y equals b to the x, then we have this 1 out in front, and so we're going to have the point 0, 1. And so then whatever we have here, if we multiply by, that's going to be our new a. And so that's going to be 0a if we have anything out in front. And since here a was 1, that's 1. But here, 0, here we have a 3. And so that means a is equal to 3. Okay, and so that means, what did we do? Well, we took 3 times whatever this b to the x was, and so that means we're taking that times uh, the y value. And so what we can do then is, since we've got a, we've got our, d being -7, all we have left is b. And so B normally in this format is going to be the 1, 0 basically. It's 1B is how it works. But in this case, whatever depends on what your B is what it is. So 1B, well, here we have 1, 9. Well, 9's not going to be our B, because remember, we multiplied the y's by 3. So if we divide this by 3, so now let's divide by 3, then we get 1, 3, and now we can say that that's our B, okay? And so we've kind of had to go backwards and reverse of what we have. So first we had to move everything up to get the y equals 0 horizontal asymptote. So
Wait,
that,
why did we divide by 3 and why did we add 7? I'm not getting that.
okay, well, do you understand how this is the horizontal asymptote here?
Yeah.
So basically what I'm doing is I'm undoing all of our transformations. And so if we've moved down 7, what I want to do is move it back up here to kind of re-engage the original equations. So originally, it's going to have some, thing that looks like this. It's going to come up here and it's going to go like this, and we're going to have a point here which is going to be 0, 1, and we're going to have a point here which is 1b. So depending on what our b is, how it's going to be determined how steep this is. But that's where I want to get to. And so what I'm going to have to do is I'm going to have to first shift this up. So I have my, this coming like this, and then it's going to go up really high after that. And so when I do that, I've shifted all the y's up by 7. So basically I'm going to shift all these y's up by 7 too. So add 7 to that, I get the 3. Add 7 to this one, I get the 9. And so that's how I got those 2 points. And so then if I would actually graph that, then I would have something that would go like that. Not very good drawing again, but, and then so then our next point up here would be 9, and I'd have my 1, 9 at that point right there. So now what I want to do is I want to say, okay, well, I've got my 0, 3 and my 1, 9. how does that compare to our original values, which we know are 0, 1? Well, if I have 0, 1 and I've gone up to 3, I've had to multiply that by 3 to get to here. So that means my a, which is going to be my multiplication factor, is going to be equal to 3. So that's where I got the a equals 3. And then I know that up here I've got the 1, 9, but to kind of go back to where we should be, to divide this by 3, I would go back to my 0, 1, which is kind of like the original, point we should have. And then my other one is going to be 1b. So I need to get back to the 1b. So I have this one. And to get back to the b, I have to divide the y by 3. And so that comes down here to this point here to the 1, 3. And so then, the original function would look something like that. And so it's been transformed by first multiplying, by the 3. So I moved up by 3 here, up 3 times here. And then after that, I shifted it down 7 units to get it down to this position. And when I did that, that put me at the 0, 4, and 1, 2. And so my new function is y is a, 3, b is also 3, that's to the x, and then down 7. And so that is how I've gone backwards and kind of unengineered what we put into it with all the different transformations. Okay, so the key point is I had to know these two are the original points for y equals a b to the x, and then kind of go from there on based on what the picture is. So I had to find the horizontal asymptote, and so in this case it was -7, so I had to move up 7. Now if I'd have been up here and had a high one, then I had to have gone down 7 because this would have been a +7, and so then all the y values would have gone down by 7, and I would have had to play with it that way, but it would have done the same thing. Once I got something 0, comma, whatever, when I have the horizontal asymptote at 0, then that's going to be my a. And so that would be whatever my a is. In that case, it was 3, maybe in a different one you would have something else, but it was stretched 3 times basically. And then because I already had my other point, the 1, 9, I knew that I had to unstretch it by a factor of 3. So I took the 9 divided by 3 and got down to the 1, 3. And so that gave me my b, and then I could just plug everything into that formula basically here and simplify from that. Does that make sense?
Yeah, I have one last question.
Mm-hmm.
So how come when you divided by 3, you only divided the 9 and not also
Because
1?
we're doing it's really 3 times b to the x, and so we're multiplying because it's y equals that. And so if we have a y is 9, to solve for b, we had to divide by 3. So we had to divide by 3 here on just the y. We're not dividing this here by 3. That's going to do something different. We're just dividing what our y value is, and that's all we're worried about in this case.
That makes sense.
Okay. All right, so this one is also in 4.2, and it's equivalent to page 353. 32 to 37. So basically shifting up and down, left and right, and reflecting across the axes. And so, this one is nice because they give you our base function and then they tell you what you have to do: 3 up, 3 right, and reflect across the y-axis. And so they could have instead said down, left, and across the x-axis, things like that. And so those are the kind of different things you might see for the actual exam.
I don't know how else to show that that's like not part of the exponent part of it, I guess.
Yeah, for typing it, that's what you do. If you use handwriting it, you just do 7 to the x plus 3. So, um, yeah, I think what you have is plenty fine. Okay, so yeah, that looks good. And so the differences would be if you had a down, you would have a negative here. If you had to the left, you would have a plus here. And if it was across the x, it would be that instead. So, pretty simple things as far as what to do. And so you don't really have, we've done a lot of transformations. So those I think are probably the easiest things for us so far. All right. So this one, when I printed off the thing, it jumbled everything up, and so I redone what it actually is supposed to say, and write it in the way it should look. And so this one is in 4.3, and these are the page 362. This is one of the real world applications there. And so the other ones would be if you had the film exposure and working on those kind of problems. So that's where this one comes from. So how's this one going?
I don't have any idea how to do this one personally.
All right, so good thing I didn't leave it as it was before, because what the question was given to you originally, you just had r equals log of I over I naught. And so then you were supposed to use the rules of logs. And so then we had two earthquakes. So then we would have labeled one R1 minus R2. And so that would have been the R1 here with, they call it R, and this one they call it M. Doesn't matter, whatever, however you want to label it. And then we would have had the first one, the log of I1 over I naught, minus the log of I2 over I naught. And so that's how we would have got those. We would have just changed it from I to I1 and I2 so we could differentiate them. And then what you would have had to do is say, okay, well, with the difference of logs, I'm going to divide those. And so that's a log of I1 over I naught divided by I2 over I naught. And so then you'd flip it over and multiply by I naught over I2 and I naught over I2. So everything down here's gone. Those cancel. And then we get what we have up here, basically. The I1 over I2 is equal to the R M1 over M1 minus M2. I can get it right eventually. So what do we do to solve this one? Well, remember, it's log base 10. And so we can take 10 over there to that power. So 10 to the M1 minus M2 is equal to I1 over I2. Now we want to know how many times larger the I1 is. So we're going to multiply both sides by I2. And so those cancel. So basically we're saying I1 is equal to 10 to the, what we have, the 7.7 minus the 6.6 times I2. So it's going to be that many times larger than the I2. And so that's how this one is going to work. And now we just have to take what is 10 to the 7.7 minus 6.6. And so if we do that, we'll have 10 to the 7.7 minus 6.6. And that equals 12.589. And so then we would get the I1 is equal to 12.589 times I2. So it was 12.589 times more intense than the other one here. And so I decided I didn't think you needed to be able to have to do all that plus everything over here. So I just put it like it was in the book up here, and they gave that to you. So I just left it so you had the same thing as they had there. So does that make sense?
Yeah, that makes sense.
Okay. So yeah, so that one is just remembering that, that's log base 10. So you take 10 to this side equals what's inside of here, and you get that. And so then you just have that little calculation is really all you have to do as far as what the question goes. All right. So then when I was doing the PowerPoint here, somehow I got out of order, and then I think I went to 4.5. So these are out of 4 point, this one's out of 4.5 on page 389. And it's going to be like 15 to 19. Basically, we're using the properties of logs to expand um, these to have no exponents, and it's either a sum or a difference depending on what we have. And so basically we're just going to try to get this whole thing and to make it so there's no exponents, no multiplication, no division, only sums and differences times some values. So I'll let you work on that one now. All right, that looks right. So what we have is with this, we're going to have, when you have, go back up, when you have the product, you're going to break it apart into adding. And so initially we're going to have log of x to the 7th plus log of y to the 9th. And then when you have a division, that's going to become subtraction. So that's going to be the log of z to the 16th. And then because of the power rules of logs, we can bring those powers down. And so then we get the 7 times log of x, 9 times log of y, and the 16 after we still subtracted times the log of z. Okay. So any questions on that one? All right, what about this one? And this one's going to be like, again, on page 389, number 33 to
It won't let me clear that off the page at all.
won't let you clear it. Well, I can't clear it either, so we'll just ignore it for now. Maybe we can just go. It's gone. Probably it's going to be still there the next page. Yep. So does anybody remember how to type this into your calculator?
I don't remember how to do that.
We have to do the change of base formula. So what we have to do is we're going to look at this and say, okay, what is the way to make this into something we can change the base for? And if I can get this to right, I'll have log of 73 divided by the log of 13. Or I could do the ln of 73 over the ln of 13. So basically, we're just changing the base to get rid of that. And so by change of base formula, it says if you have log base b of m, that's going to be the log of m over the log of b. And again, if you want, you can use ln, and it should give you the same thing. And then you just plug that in your calculator, and you'll get your value out. So all you have to do is just type in those two numbers, divide them, and you're going to get the actual value. So I'll let you see if you can get the right answer there. Yep, that looks good. Good job, Ben. All right, so that's how we do that one. We've out of time for today, so tomorrow we'll go ahead and start, and this will be the next group we're going to work with, and so we'll begin those tomorrow, and then hopefully everybody will be ready for the test. Any questions before we go?
After tomorrow, is there any chance
Any chance
you'd
what?
be able to send us? All right, now that we muted her, if there's any chance you could send us another one for the weekend, I'm wondering, just a randomly printed off one. Would that be
I don't know if I can print off another one to make it look good, but I think if you go through the things I've been kind of showing you, that'll be a good idea, because if I give you the same one with just different numbers, then it might not group them so you get all the same things. So I think if you know, like on this one, if on 4.5, if you can do any of them between 15 and 19, and maybe just do the odds so you can check the answers in the back of the book and make sure you can do those. And then on like 33 to 37, again, just do the odds so you can check yourself. I think that would be a better way than actually me printing off an exam, because then you'd actually have like 3 of them on each that you could practice instead of just one more. Does that make sense?
Oh, yeah, it does. Thank you very much.
Sure. All right. If nothing else, I'll let you go and I'll see you tomorrow.